already done it, but I especially want to again welcome everyone to our meeting. And I want to say a special welcome to Tamara of New Kingston, to the Kiwanis family. You say you got inducted last week. Welcome to the Kiwanis family. I think we should be celebrating your 35th with you tomorrow. So I'll be there. So make sure when I get there, you point out that, hey, this is Tamara who was in your meeting yesterday. Would love to meet you.
Will do. But I will tell you we have met before when you meet me tomorrow.
Well, I will probably look at you and say, oh, it's you.
Okay, same way. Okay, then thank you very much for that introduction. And welcome.
All right. Apologies for absences. Well, as everyone will notice, Dale G. Willie is not on, because just as the meeting was starting, he called me to say his internet went. So he is fighting to find a way to come on, but he's not on as yet. And we know that Treasurer Orville is overseas. I don't know if any of our members have any apologies from anyone else. No? All right. Moving quickly, because we want to hear from KARLEEN Black. So we will go straight back to PD Stephen, who will take us through recognition of birthdays and anniversaries.
Indeed. Thank you, President Newton. So for this week, that is a week of September 3rd to the 10th, we have two Kiwanians and their partners who are celebrating birthdays. First of all, past Chairman Carrington Grant, he celebrates his birthday on the 4th. That is, today's the 3rd, so tomorrow, Wednesday the 4th, he has his birthday. And also on the 4th, PD Gladstone Mallet and his wife Faye will have their wedding anniversary. So birthday greetings to Carrington and special greetings to Gladstone and Faye on their anniversary. And just to tell people, and I think most people will know this just from their general experience, but it is, I found this interesting because it has been tested scientifically. So the celebrations of birthdays and anniversaries and occasions like that, they found it boosts happiness, it strengthens your relationship, and studies have shown that the occasion tends to create lasting memories, reinforce bond with loved ones, and it increases your overall well-being. So it's not just something that we should take for granted, whether you're very young or very old. Celebrating birthdays and anniversaries does scientifically benefit you in the long run. So with that note, President Newton, back to you, and birthday greetings to everyone for this week.
Thank you very much, President-designate Stephen. And for those non-Kiwanians on board who are wondering, why am I calling him PD Stephen? PD really means President-designate. It means within a month's time, or in a little less than a month, he will be the new president of the Kiwanis Club of Kingston. All right. At this time, you know, we never, one of the things that we never do at Kiwanis Club of Kingston, we never lose an opportunity to give to tell people something about Kiwanis. Some people are hearing it for the first time. Some persons it's just reinforcement. So at this point, we're going to have LG, and LG stands for Lieutenant Governor Desmond Batchelor with our Kiwanis education for this evening.
Thank you, President Newton. Good evening, everyone. The topic is dues, membership dues. Kiwanians are obligated to pay their dues in order to be in good standing. And the dues become payable October 1. But to be in good standing really means, and by the Kiwanis Club of Kingston bylaws, is that you ought not to be in arrears for more than 3 months. Some clubs may have 3 months, some may have 2 months, some may have more than 3 months. And by being in good standing too, some may include attendance at meetings and participation in club projects. But in our case, it's really only in respect of payment of dues. So if you're in arrears for more than 3 months, you're not in good standing. Members not in good standing may be suspended, removed, or removed by no less than a majority vote of the board, and at least 14 days prior notice of such pending action. Pending action would be suspension or removal, must be provided to the member. The member will have the right to appear to present his or her case to the board on or before the meeting at which such action will be determined. That is it for Kiwanis education, President.
Thank you. Thank you, LG. And I need not add, but I will, that remember persons, whether you're a member of the Kiwanis Club of Kingston or some other Kiwanis club, the club depends on your dues to take care of its administrative matters. And without those dues, then the club is operating with shackles. So any member who is online now, and as I said, not just Kiwanis Club of Kingston, if you haven't paid your dues, remember, you don't have to pay everything one time, but you do need to pay the dues. All right. At this point, we are going to have introduced to us the person who we all came here to hear. And so our chairman, Martino Dyer, will at this point introduce our guest speaker. Chairman Martino.
Able to hear me?
Loud and clear, sir.
Great. All right, so Ms. KARLEEN Black is a scientific officer at the Earthquake Unit at the University of the West Indies, Mona. She received her bachelor's degree in geology from the University of the West Indies, Mona, and has a master's degree in disaster management with a specialty in seismology from the National Graduate Institute for Policy Studies in Japan. She consults regularly with various government and private institutions, the parish councils and schools, as well as the media, and to help educate Jamaican public about earthquake hazard and the risks faced by the Jamaican given its geographical location to a plate boundary zone. Since July 2017, she has served on 4 of 7 national disaster risk management committees, which steers disaster management, response, and recovery. Ms. KARLEEN Black.
Good evening, everyone. It's my pleasure to be with you. I hope all is well with everyone. And I hope that by the time I'm through with my presentation, there won't be any fear, but rather a lot of understanding. So I will now share my presentation. Can everyone see me and see the presentation?
Yeah, yes, I can see.
Yes, we can.
Okay, so what I'm hoping to do tonight is just to demystify some misconceptions that persons may have about earthquakes and what causes them and so forth. So we'll start with what is an earthquake. An earthquake is basically a sudden shaking of the earth caused by breaking and shifting of rocks along lines that we call faults, and this happens beneath the surface, so within the crust. Here I'm showing you just a generalized view of some of the fault lines that are in Jamaica. So all the lines that you see, except for the arrows going across Jamaica, those are all faults, and you can see that they are everywhere. So in terms of plate tectonics, how do we know where the plate boundaries are? Well, what happened is that over time, seismologists in compiling and plotting earthquake locations around the globe noticed that they all clustered in specific areas and they form outlines. And the image, a small image to the left, is showing you many black dots that are clustered together to give you a sort of jigsaw puzzle, and all these dots are really earthquakes. So earthquakes are what happen at plate boundaries, and it has to do with the movement of the plates. And of course, the image on the right is giving you a better picture of what earthquakes actually, what the boundaries actually look like for the plates. Right smack in the center of this picture, you will see Caribbean plate. And if we get a little closer, so the image on the left is showing you again a cluster of earthquakes. In this instance, there are many different color dots, but the dots only give an indication of depth. So all the dots are earthquakes. And you can see that again, the Caribbean region is enclosed by all of these dots. And to the right, you see an image with an arrow in the center saying 2 centimeters per year. And this is indicating that the Caribbean plate is moving eastward with respect to the North American plate, which is above, that contains Cuba and America at a rate of 2 centimeters per year. So what is really happening is that the Caribbean plate is really stationary, and what we're seeing is a relative motion. And this relative motion is brought about by the upwelling of fresh magma into the seafloor along what we call the Mid-Atlantic Ridge. And I'm just using the zoom pencil here. You see these red dashed lines. Well, this entire structure coming down almost all the way to Antarctica, that's the Mid-Atlantic Ridge. And along this structure, what you have is fresh magma coming up from the mantle and pushing old seafloor apart. And so, in fact, it is growing the Atlantic Ocean. So as this happens, you will have one side moving to the east towards Africa, and other side of the seafloor moving westward towards us and Central and North America. So Central and North America is in fact attached to this movement, and it's this movement that is pushing them in a westerly direction. But Caribbean plate, in fact, is stationary. So here I'm showing you a better, give a schematic view to give you a better understanding of what's going on. So in the center again, you will see 2 arrows moving away from each other. This is what is happening at the Mid-Atlantic Ridge. So you have the magma coming up, and we call this a divergent boundary because the plates or the seafloor is being pushed away from each other. Where we have the very dangerous earthquakes is what we call a subduction zone. And this is where 2 plates collide, and one of 2 things can happen. They can either be of the same strength, that is the plates, and so they grow into mountains such as the Alps, or if one is stronger than the other, then one gets subducted and is pushed into the mantle while the other rides over it. And this is what we call a subduction zone. And it is in this area where you find you have the most dangerous earthquakes. So these are the type of earthquake motion that will give you the magnitude 9 types of earthquakes, as well as volcanoes, and of course, tsunamis. Fortunately for us, we are in a less dangerous type of zone. And here, as you can see in the top left, for this little schematic diagram, you see that the plates, one is moving to the right, the other one is moving to the left. So they're simply sliding past each other. And this is what we call a transform boundary. And in these areas, you don't tend to get the big magnitude 9 earthquakes. And of course, because it's a simple sliding motion, even if it's in the sea, it doesn't usually generate any tsunamis. So to summarize, the plate motion that we see, this 2 centimeters per year eastward, is really due to the westerly movement of the North American and South American plates as they are pushed by the Mid-Atlantic Ridge. So the Caribbean plate is stationary. So let's talk a little bit about two of the terms that people tend to get confused before we get any further, and that is magnitude and intensity. Now, magnitude is a measurement. So you actually do calculations. You take readings and you do calculations to derive a number. And this number will tell you about how much energy was released by the fault during its motion. And, so that is what we call magnitude. And it's really just a measure of how much ground motion, how much the particles in the ground are displaced up or down by the seismometers. In terms of intensity, it is a qualitative measure of what we see and what we experience during an earthquake. So if you see trees swaying, or if you heard a rumbling noise, you saw buildings falling down, that sort of thing. So it's not really an empirical measurement then, it's just an estimate based on what you experience of how strong the earthquake was. In terms of the magnitude scales, well, all magnitudes, earthquake magnitude scales are logarithmic scales, and they range from 1 to 10. Where Mr. Richter came in is that he had a specific, he was the first one to start using a log scale to try and quantify the earthquake vibrations that persons were experiencing with his instruments. So he would use a specific kind of instrument based on movements of the seismic waves in a particular area, that being Southern California. And so the Richter scale, as many persons think of it, is not really a physical entity that measures an earthquake, but it's rather calculations that were done by Mr. Richter to pioneer what we now use for magnitude scale using the base 10 logarithm. So in terms of there are other types of magnitudes, and in fact, no one today uses Richter magnitude. They will use their own local magnitudes or use other portions of the seismographs with modified equations to get other magnitudes. The most standardized one currently in use is called the moment magnitude. And really, when a fault moves, it's, the earthquake is not really caused by movement at a point. It's really an entire surface area of the fault plane that you have to calculate the movement. And there's a property called the moment, which is proportional to this motion. And so what scientists do now is they measure that to get an idea of just how much of an area of the fault moved, and therefore get a more accurate reading as to how strong the earthquake is. So in terms of magnitude, you might hear that we had a minor earthquake, or we had a light earthquake, or you hear talk of great earthquakes, that sort of thing. Well, this is a specific magnitude classification that is used worldwide, and all these terms have specific meanings. In our case, we more frequently get the micro and the minor earthquakes. But of late, as you know, we have been getting the moderate earthquakes, which you see in bold lettering on this table. So in terms of a major earthquake, that would be a magnitude 7. And some of you have been speaking to me and other members of the society about talk of us getting a magnitude 7. And I'd just like to say that here we in the Northern Caribbean, where we are with the type of plate motion that we get, we are considered a moderate zone. So more often than not, we will get at least one magnitude 5 earthquake. So us having 2 in a short period of time is still not alarming. It might not be what is the norm for our lifetime, but it is within the range of what is expected for a moderate zone. So how do we measure earthquakes? Well, first we have to detect them using our instruments, which are seismometers. And for the image on to the far left, you will see that there are 3 cylindrical objects, silver objects. These are seismometers. 2 are on their sides in a horizontal position at right angles to each other, and another is vertical. And I will come back to this when we speak a little further about the measurements. And of course, we have digitizers and antennas to digitize the signal and send them via radio waves from all over the island. So this is a basic mock-up of our network back to us at the University at the West Indies Earthquake Unit. So when we analyze these readings that we get, this is done in our computers, you know, because the instruments themselves can't tell us anything except how much the ground moves. It cannot give us the magnitude or the epicenter or the depth or the origin time, which is the time at which the earthquake started before it reached any of our seismograph stations. So in terms of Mr. Richter, how he would have done it, for those of you who can remember slide rules and all these logarithmic charts, what he would have done was measure the amplitude of some of these seismograms, I should say, and then he would use that to find the distance, how far away these earthquakes were. And as I mentioned, there are 2 types. The seismometers that we saw were oriented in particular ways. And there are 2 types of earthquake waves, 2 main types, the P and the S. P stands for primary, S stands for secondary. P waves move faster than S waves. S waves, the speed of them are about 60% that of the P waves. So they both start out from the source of the earthquake at the same time, but as the distance increases, they will start to separate because one is moving faster than the other. So he's going to use that to figure out how far away the earthquakes were, the earthquake was. And once he has that, then he can use this 3-scale setup that you see here with magnitude in the middle. And he was able to do this by measuring earthquakes over a long period of time to get an idea of the strength of the earthquakes. So with this setup, he would have physically used a ruler or something of the sort to draw a line from the distance graph to the amplitude graph to see at what point it crossed the magnitude graph to know what magnitude the earthquake was. So we all do it the same way now, except that we have what we call travel time curves, which is the graph you see on the right. And so in this example, I'm showing you, you have 3 stations on the left, and you can see the seismogram for each station. And you can see that the P and the S waves have been indicated. The time difference between them is also indicated. And this is used by the simple principle of distance over time gives you speed that we all learned in high school. That simple calculation will then, relationship I should say, would then give us the distance, how far away the earthquakes were. So once you know how far away the earthquakes are, you don't know what direction it's coming from. So you would need to have at least 3 of these seismograph stations. And then you use the distance as the radius to draw circles. And where the circles overlap is where the epicenter of the earthquake would be. And of course, the epicenter is the point, is the coordinate on a map that you would plot on a map on the surface, whereas the earthquake would have originated vertically below that point at depth. And that is what we call the focus. Okay, we have already covered our moderate zone. So let's talk a little bit about the effects of the earthquake. Of course, the obvious one is ground shaking. That is the one that most of us fear. But you will also have other effects caused by the earthquakes, such as landslides, liquefaction, tsunami, and even fire. In the case of landslides, for the Jamaican context, we're a mountainous countries, the mountains have very steep slopes, and there's a lot of erosion and so forth. So wherever you have unstable slopes, the shaking from the earthquake can trigger a landslide. Liquefaction, this is where you have very fine sediments, particularly sand size, and a high water table. So the shaking will have caused the pressure of the water in the soil to increase and force the grains apart, making it similar to quicksand. And of course, hence the term liquefaction. So everything is now too heavy to be borne by the soil and they start to sink or tilt. Of course, tsunamis is the displacement caused by the earthquake of the seafloor, and that will generate big waves that can circumnavigate the globe in a very short period of time. And of course, fire, we don't use gas lights as in the 1907 earthquake, but we still have gas stoves, we still have other petroleum products around which can cause fire. And this is just to summarize all the dangers. So what can we expect if we have an earthquake? The 4 aspects that I would like to focus on are aftershocks, the severity of the earthquake, what type of damage to expect, and any kind of disruption or potential for disruption. So from the historical context, the majority of the earthquakes, the damaging earthquakes that we have had here in Jamaica have occurred in the east. And you can see I have in red here the 1692 earthquake at the top that destroyed Port Royal and the 1907 earthquake that below that destroyed Kingston. I would also like you to note that the 3rd column, which says max intensity, that the numbers are actually Roman numerals. And this is another difference between magnitude and intensity. So if you see regular numbers, it's usually magnitude. And when you see Roman numerals, it's gonna be about the intensity. So that was the east. And for the rest of Jamaica, you can see that they are not as dangerous, but nevertheless, we have had strong damaging earthquakes from both West and Central Jamaica. So when you have a big earthquake, it is common to expect, and you will have aftershocks. And this diagram that I'm showing you here, the top left diagram, I will use as the control diagram. So we'll call that normal activity. And I'd like you to note that Jamaica is always active. You know, Blue Mountains is covered by earthquakes. All these dots are earthquakes. So we'll use that as the control. The figure top right is a map showing you the distribution of earthquakes after the magnitude 7.7 earthquake in January of 2020. And you will notice that that area that oval area I have in pink, you know, has a cluster of earthquakes within it. And these are the aftershocks that were triggered by that large earthquake, that large magnitude 7 earthquake. And for comparison, if we look back at the year before to the left, you see that there was very little activity. Now, if we go to the bottom figure 1 year later, so this is 2021, you will notice that things have more or less gone back to normal for the area in the Cayman Trough where you had the 7.7 earthquake. But then over in Haiti, they had a 7.3. And now when you compare this area, you will see that it too has generated a lot of aftershocks. And so the activity has increased, the earthquake activity has increased compared to 2020 or 2019, which are the maps above. So the whole point of this is that when you have a strong enough earthquake, say magnitude 5 or above, you are to expect and you will get aftershocks. The aftershocks won't be as big as the main earthquake because by their definition, they are smaller. If it was bigger, if an earthquake occurred that was bigger than what you thought was the main earthquake, then in fact, what you thought was a main earthquake would have been a foreshock. So aftershock earthquakes are always smaller. So the magnitude 5.6 that we had last October, the biggest aftershocks that we have had were in the magnitude 4 range. And of course, smaller. For the 5.3 that we had just the other day, we also don't expect anything larger than a magnitude 4 for aftershocks. And of course, that will play out with time. There isn't a specific trend for aftershocks, so they can go on for weeks, months, or even years. So depending on the nature of a particular region, the aftershock can be over very quickly after a big earthquake, or it can be prolonged and go on for years. Now, in the case of the October earthquake last year, we are still having aftershocks. So it's dying down in terms of frequency, but in terms of the duration of the aftershocks, we expect that we would still be having them, perhaps even into next year. So this is just an overview of last year's activity, what we call the seismicity. And for last year, it was a bit unusual in that all the felt earthquakes were in the east of the island in Portland and St. Thomas. And again here, just to underscore and emphasize about aftershocks, you will have a lot of them immediately after a big earthquake, but with time they will fall off. And if we look at the magnitude 7.7 earthquake in Cuba, so that's the red arrow pointing down to this orange bar on our graph. This is showing you the accumulated earthquakes, regional earthquakes for that period, so the area immediately surrounding Jamaica. And you'll notice that the bar is very high compared to the years prior. And this is all because of the aftershock activity caused by that earthquake. If we move to the far right, to the year 2023, the purple would indicate local earthquakes. And for 2023, it was looking to be a pretty normal year until we had that earthquake in October of October 30. So until that earthquake, everything was normal. And then suddenly, because of that earthquake, we are now having many aftershocks. And thus far, we've had more than 100, well over 100 aftershocks since then. So it's just the general nature of having a strong let's say having a big earthquake. So it's nothing to be overly panicked about or overly concerned about. After you have a big earthquake, you are going to have aftershocks. But of course, they will be smaller than the main earthquake. So in terms of this severity of the shaking and the damage and any disruptions, what do we need to consider? Well, of course, the strength of the earthquake, the bigger the magnitude, the more the energy, and so the more the shaking. So yes, you would expect a bigger magnitude earthquake to have a worse effect or a more severe effect than a smaller magnitude earthquake. But that's only one part of the story. We also need to consider how deep the earthquake focus was, because shallow earthquakes will cause more damage than deep earthquakes. So let's take the two magnitude 5 earthquakes that we have had so far. We had the October one last year, and we had one just the other day, magnitude 5.3. Although they're only about 0.3 points in magnitude apart, so they're more or less the same strength. The one last October, if you can recall, it felt much stronger and you shook for a longer time. And the main difference between those two, since the magnitudes are so close, is the depth. Last year, that earthquake was a much more shallow earthquake. It was about 18 kilometers, whereas this one was deeper at about 27 kilometers depth. So depth does make a difference, even for a magnitude 7 earthquake. If you are in an area and a magnitude 7 earthquake occurs, say 100 kilometers beneath that area, even if you feel it, in many instances, there won't be much damage, as opposed to a similar strength earthquake occurring at 20 kilometers depth or less. So depth also plays a very strong part in how the earthquake affects us. The third thing that we have to consider is location and what we call site effect. So in the case of location, let's say we have a similar movement to our plate boundary where movement of the fault is in a westward direction. If you are located somewhere to the west of an epicenter along this fault, the fault is going to be moving toward you, and therefore you're not just going to feel the vibration caused by the movement, but the force of the movement itself will also be in your direction. And so if you are 10 kilometers from the earthquake epicenter, but to the west of it, you are going to feel more shaking. You're going to feel stronger shaking than a similar location at 10 kilometers to the east, because the movement was away from that location. So this is where directivity comes in. So if the movement is toward you, you are more likely to feel a stronger shaking than if the movement was away from you. Another thing that you need to consider for site effect is the rock type. If you are on solid rock, you are going to shake less than if you are on loose soil. Similarly, if the stronger the rock, so if you have very hard, strongly compacted rock, that too will shake a lot less than a softer, let's say a marl type of rock. If you are on loose sediments, let's say here on the Ligani Plain for Kingston, if you're on loose sediments, you will shake stronger, but one location on the Ligani Plain may have more damage than the other, and that depends on how much sediment deposit there is, how deep that deposit. The deeper the amount of sediment, the stronger the shaking is going to be. In terms of other properties, again, let's look at Kingston, Ligani Plain. As you know, we have mountains to the north, northeast, and to the northwest. So the plain is actually sort of like an open-sided, a bowl that opens to one side. What can happen with sediments in such a bowl is that you can have the earthquake waves being reflected against the side of the bowl, and so the earthquake waves become trapped, causing you to shake for a longer period, and sometimes it can cause what we call amplification. So the earthquake waves, they start to get stronger and stronger because there's a positive interference with all the reflections that's going on. So, so in those instances, you have to consider where you are, what your structure is built of, and what the foundation of the structure is. Another thing we need to consider, this is the final thing I'll mention, is if you are at the edge of a cliff, you will also tend to shake more than if you were further away from the cliff. So if you on a mountain, if you're at the edge, you're gonna shake more than if you were, say, closer to the peak and so forth. So those are the things that you need to expect when you build, or if you're just out walking and traveling and there's an earthquake. That is the sort of thing you need to think about. So of course, we said you can have lots of damage for a major earthquake. And so if we consider the Kingston earthquake or the Port Royal earthquake, both of them would have had landslide, liquefaction. In modern day times, it would have resulted in blocked roads, there would have been significant damage to buildings. You would have ground cracks and fissures, ground settlement, and of course, utilities and communication lines that are either in the ground or on fallen utility poles will also be affected. And again, we can have tsunami, but in our case, the tsunami would be more caused by, say, a submarine landslide, because just like the mountains, the offshore shelf is also quite steep, and so the sediments tend to be unstable. So if we look at the Woodford 1993 earthquake, which was a 5.4, what we noticed with that earthquake is that the damage pattern was quite similar to that of the 1907 earthquake. And if we look at some of the damages that they had then, you would have seen that landslides caused disruption to the Yallahs pipeline. There was damage to NWC treatment plants and so on. So this is telling us that if we were to have a major earthquake that is a magnitude 7 size earthquake, we should expect to have these sorts of issues. And of course, this then tells us how we would need to prepare for such an earthquake. So based on what the damage pattern that we notice, we know that there may be disruptions with water and electricity as well. The image that you see on the right is actually a manhole that has floated up to the surface because of liquefaction. And as I explained earlier, with liquefaction, the ground becomes like quicksand. And so because of the air in the manhole, it actually floated to the top. So this is another thing that could cause disruption in terms of logistics and transportation, in, whether it's to get relief to affected areas, or even just for rescuers to get to where you are if you are in need of rescue. So in terms of our social behavior and decision making, there are certain consequences that come with that based on these observations. So for one thing, we all like to live close to the coastline. So here in Jamaica, most of our major settlements and much of our commercial activities, even the hotels, are all along the coastline. So this means that we have a lot of risk exposure if there's a strong earthquake, because along the coastline, you have loose sediments. If you're right at the beach, then you have the water table to consider, so you may have liquefaction and so forth. From a convenience standpoint, easiest route from the north coast or from the south coast to the north coast is through the mountains. But of course, when you cut rocks through the mountains, you're going to have environmental issues. So the rock cuts can lead to landslides, whether you have an earthquake or not. because water is a very good lubricant. So if the slopes are now unstable, then and you have a lot of rainfall and so forth, you can have landslides, and we have that every year. But also it can expose our watersheds. So if we're having climate change and then we're losing trees as well due to landslides, that can also have ramifications. And of course, in terms, not just for the coast, but the other environmental issue that we need to consider is contamination of our water supply and our marine environment. Because whether you're inland or at the coast, if there's any oil spill or any chemical spill, that sort of thing that gets into the water, then we could have a crisis on our hands because we won't have any clean drinking water. So these are just some things that come about based on the lifestyle and the decisions that we make that we all need to reflect on as we go forth and try to be safe from a major earthquake. I will pause here and ask if there are any questions. I'm not sure how much time there's left, because this is just basically about what to do during an earthquake, the usual drop, cover, and hold. So if you want me to stop here, I can stop here and we can discuss in more depth what I have covered.
Okay, Ms. Black, yes, we could just pause here and take some questions if there are some questions that people would like to pose. I think I see a hand up. That Tamara Morrison. If that's you and you have your hand up, then you can go ahead.
Thank you. I just had one question because I noticed that people still correct me if I say earthquake and they are saying tremor. What do you categorize as a tremor versus earthquake? Is it all that we're feeling, all earthquakes, when we actually feel it?
Yes, everything is an earthquake. So it doesn't matter whether you say tremor to try to make it seem not so dangerous or make it seem nicer or something like that. Regardless of what you call it, it's all earthquakes.
Okay, I was just wondering if there was anywhere on the scale that after it goes
No.
over 0.3 or something. Okay, thank you.
No, there's no scale. It's all earthquakes.
I did have a question, Ms. Black. The last point you touched on about the groundwater. It doesn't appear to me though that there's anything you can do to prevent contamination of the groundwater if the earthquake is strong enough. Am I correct?
Well, it all depends on how we prepare. You know, if you're at the coast, then it depends on how well our petroleum refining installations prepare for such an event to prevent spillage. Similarly, for the electricity generating barges and so forth. But and as far as being inland is concerned, well, as individuals, whether it's a private home or a company, you know, how we store our chemicals and other harmful materials is very important. It can be prevented. It's not a sure thing that we will get the contamination if we do the right thing.
Oh, so you were talking about installations like when they have tanks in the ground and that kind of thing. I thought there was also a risk of contamination. So if nothing is buried, then if that was the situation.
No, it doesn't have to be buried, you know, because if the tank is above ground, but it was in poor condition, maybe the foundation or something, and it fell over or cracked or something like that, then you will get contamination. So I'm saying it depends on how well you maintain and, you know, repair things and how you site them in the first place.
Okay, but then there would have to be standards that would
Right,
precede.
right.
So where are
Right.
those standards? Are those part of the building codes? I'm not aware of that. I don't know.
I am not sure about chemical stores and stuff like that. But I'm sure there must be. I mean, we have OSHA standards, so there must be some standards. Perhaps it's an OSHA standard,
Okay.
a safety standard, but there should be standards. Maybe we can consult Bureau of Standards or one of those agencies to find out
Alright.
exactly what it is.
Okay, there are some answers. I can't tell in sequence, but let me go with President Newton. Okay, President Newton. I don't know if you want to do the extension now. Is that it? Not
It's at
hearing you.
8:14. We still have 60 minutes to go. I have a quick question. Because I listened to a presentation recently. Ms. Black, by the way, great presentation, Ms. Black. I listened to a presentation recently that said that a magnitude 6 earthquake is, well, a magnitude 7 earthquake is way beyond what a magnitude 6 is. Oftentimes we think a magnitude 6 and magnitude 7, hey, they are in the same region. But now that I look at your chart that says a magnitude 6 is strong, but a magnitude 7 is major. Can you give us an idea of what maybe a magnitude 6 is something where buildings will shake, but a magnitude 7 buildings will definitely fall, something like that?
Well, I wouldn't say definitely fall, but you have more potential for damage. In terms of energy, okay, in terms of how the ground moves, because we're dealing with a log scale, remember, and it's base 10. So it means that you would have 10 times the ground movement for a 1 magnitude difference. So a magnitude 10, a magnitude 7 earthquake would cause the ground to move 10 times more than a magnitude 6 earthquake. But we also need to consider the energy, which is a more efficient way of measuring, of comparing the magnitudes. And when you look at the energy is actually 32 times more. So yes, there's a very, even though it's just 1, there's a very big difference between a magnitude 6 and a magnitude 7 earthquake. 32 times the energy.
Thank you.
Yeah, I think one thing that would help to make it even clearer is to get it out of our mind that it's a linear scale, and remember that what logarithms really meant. So that I'm glad that point has come out. Okay, I see Director Peter Allen. I'm gonna go with it in the, okay, let's go with Director Peter Allen.
Thank you. Question is but I ask a similar question, but I wanted to re-ask it, because the question is the water storage underground affected? I think they're talking about maybe aquifers or rivers. If an earthquake, that energy that is dissipated can actually disrupt the natural underground water system and cause contamination.
Well, it can disrupt, but it wouldn't necessarily cause contamination. It's what we do. It's what we have on the ground that would cause the contamination. Other than say for a tsunami, if you had the sea coming in and then you have saline intrusion in the ground, making it unfit for agriculture. But the other chemicals that we're using, it is if those storages get broken and get into the water table, then that is what I'm talking about. So it's not necessarily that the earthquake shaking itself will cause damage to our aquifers or anything like that. It's the man-made chemicals and other storage, other potentially poisonous solids or liquids that can leach into the soil and get to the water table. That's what I'm talking about.
Okay.
Thank you. An
Okay,
excellent.
Okay, thank you
Thank
for
you.
that question. Stephen, great. Let me go to Stephen.
Okay, thank you, PD, Stuart. And thank you, Ms. Black, for your presentation. Very informative, very knowledgeable. My question has to do with a few months back, there was an earthquake in New Jersey. And when I looked at your map, I noticed that no fault lines were close to New Jersey. So my question was, can you clarify how New Jersey would experience a noticeable earthquake, yet it's not close to a fault line?
I'm sure that there are faults there, but it's not and probably not listed as active, because areas such as New York and New Jersey, the fault lines there are so ancient that they would have more or less ceased activity, but it's not a complete cessation. So occasionally they will get earthquakes, even though they're not at a plate boundary anymore. They will still get earthquakes occasionally, but they're usually not as strong. And but the danger with those areas is that the crust is a lot cooler, and therefore it is more brittle. So a smaller earthquake could have just as much damage as, a larger earthquake at one of the plate boundaries. So that is the danger.
I see. Okay, thanks. So that means that it is possible to be in New York City in a skyscraper and there be an earthquake. It's not that they're immune from faults and earthquakes, but it doesn't happen very often and it's not projected to happen. Okay, as compared to Los Angeles and so forth.
Right, correct.
Okay.
Okay.
All right, thank you.
Thanks for that. Thanks for that, Stephen. Let me go to DLG Bell. I think your hand is up. Go ahead.
Yes, thank you so much. I just wanted to ask, is there any scientific proof that severe heat, and after you've had a really hot day and then it rains heavily after, can bring on an earthquake? Is there any truth to that?
No, not at all. And if you recall some of my figures where I showed you the magma coming up to create new seafloor, that heat is so strong that, the temperature difference that we experience in terms of climate, would not have any effect at all. So no, climate doesn't affect earthquake activity in any way.
Oh, okay, thanks.
But you did say something about climate change. Link the two for me, because you did mention climate change.
I'm trying to remember in what context.
Yeah, I don't remember the context either. All right, let's go on then. I see another hand up. Oh, quite a few more hands, but this one was up. Indy Goldburn. Indy, you go ahead.
Yes, it is.
All right.
Good night,
This hand
everyone.
has been there, DP, Stuart.
Say again?
In this hand has been up for some time.
Yeah, she's the one I called on. Go
Yes,
ahead, Indy.
good night, everyone. It's not such a complicated question, but I've always wondered why the aftermath of the earthquakes are called aftershocks. Isn't it also the aftershock itself also an earthquake?
Yes, the aftershocks are earthquakes. It's just to indicate that these earthquakes that you're experiencing are occurring in the same general area as the bigger earthquake. So to indicate that it's the settling, because when you have a big motion, because you're dealing with tons of rocks for many kilometers, you know, and at depth, it takes time for everything to settle down. And so aftershock is just a term to indicate that the earthquake activity is as a result of that initial movement, and it's in the same general area.
Okay.
Okay, I would think that it's the plates and the rocks going back in place, like they shifted, like they're going back. So that would also like another earthquake.
No, she said it is another earthquake. It's
Yes,
just that
it is
it is
another
described
earthquake.
as an aftershock, but they are all earthquakes. Okay. All right, let's go to Sherman, Scott. Sherman?
Yes, good evening all. So mine is a question for being a tenant and earthquake. So I'm in a house and there are little tremors out there in Helsha, and there's crack that keeps coming in the wall. Now the landlord is saying I'm supposed to be the one to fix that. Is there a number I can call to prove that it's earthquakes, little quakes that is causing these cracks in the wall, so that I don't have to be the one responsible for fixing it?
That's a tricky one. I can't think of, well, if you call any numbers other than perhaps the odd pen you may need to pay, because it sounds like you would have to get an engineer to prove that. But if it's cracks in the wall, so what is the landlord think
Can
you're
I
doing?
answer that, please?
Yes, go ahead.
If there are cracks in the wall and there are damages, peril insurance is what takes care of that. So your landlord should actually have peril insurance, because that is what peril is, a natural disaster. Earthquakes falls under peril insurance. I know the NHT offers peril insurance for natural disasters, but not a lot of people take advantage of it, you know. I myself haven't, Portmore people haven't. We get a lot of damages when there are earthquakes. Cracks and corners open up in our houses, especially the prefab houses. And
Right.
those that are still under contract, mortgage contract with the NHT, or your persons should, some developers, I don't know, so I can't speak to the developers, but I know NHT has peril insurance. So that can be claimed on. Not a lot of people know, but it can be claimed on and should be claimed on.
I've never
So you can
heard
ask
of
your
it.
landlord if he has insurance, peril insurance on the property.
Yeah, but even if he doesn't, I don't say it can't be the tenant's responsibility. You know,
Exactly.
I suggest that
That's a lack of knowledge. That's
yeah,
ignorance.
yeah. You know, if I mean, you shouldn't have to consult a lawyer to prove that, but I'm sure in the event, or maybe better still, just move out. Yeah, it's ridiculous. How can a tenant? What could you possibly have done to cause the cracks in the house? You know, I can't figure that one. Anyway, let's
That's
go on to the
ignorance.
next. Yes. So don't let him intimidate you, my friend. Please don't let him intimidate you. You cannot be your fault. All right,
Thank
Marie.
you.
Marie, your hand was up. Bev, is your hand up again, or is it, or was it, you just didn't take down your hand? Didn't take down the thing.
Oh, sorry, I didn't take it down. Sorry.
Okay, good then. Okay, let's go to Marie.
That's Merle.
Marie? Oh, Merle. Okay, sorry.
Okay, thank you. I wanted to find out. I understand you said that Jamaicans usually have moderate earthquakes between 5 and 5.9. Sometimes you hear that every so many years, 100 years, 200 years, you have a massive earthquake. What do you think in terms of Jamaica and that? In terms of, do you think in another X amount of years we're going to have another massive earthquake?
Well, it's all conjecture because we don't have sufficient historical records. But based on what we have seen thus far, it's unclear because look at the great difference in time between the 1692 earthquake and the 1907 earthquake, which is the closest in terms of destruction to the Port Royal earthquake occurred. Port Royal was 1692, and it's more than 2 centuries later that you had Port Royal. So, you know, it's hard to say if we're going to get a magnitude 7 in our lifetime or our children's lifetime. We don't know. It's all conjecture.
Okay,
May I just add something to your question, right? When we remember when I refer to 100-year this, whether the 100-year storm or 100-year earth, it's a probability analysis. It's a probability.
Yes.
In fact, you
Yes.
could have 100-year one right now. It's not really one, but it's just a probability that you would have that one following in another within 100 years. But it can happen right now. So we really can't speak to whether it could happen next year or this year. It can happen anytime. So that's how the probability works.
And may I add to that? I think if since there isn't any data to make an analysis based on the time or era within which an earthquake occurs, what could be done is persons look at the data within a specific time and the movements of the plates or what goes on within the Earth's within the crust or under the earth, whatever you call the layers. Look at how the layers move, judge it within what is recorded to see if there is any merit to say that an earthquake or earthquakes occur within 100 years or a 200-year era or 50-year or whatever. Or
Let me
even
ask
one.
you, let me ask you something. Let me ask you something. Are you speaking from a position of knowledge in this particular area?
No, I'm just
Oh, well,
thinking.
you see, I want to be
practically.
careful then. I must want to be careful because I don't want us to
I'm
use.
just the movements under the.
No, I don't want us to use our own internal logic to.
No, I'm
on
saying
this.
unless.
No,
I'm
here,
saying.
hold on, please. I heard what you said. But as I said, when you pass on information, I prefer if it was from an informed position, because then other people will take what you're saying in a particular light. And now that you have said, no, it's not from an informed position, then I prefer if we didn't say it. Okay? That's all I'm saying. It will might cause confusion. Yes, President Newton.
I'm sorry to break, but if I might, can we ask some member of Kiwanis Club of Kingston to move for an extension of 10 minutes?
Yes, so President Newton.
Okay.
Second. And seconded, okay. And then I think the gentleman from Earthquake Land, DP Paul, has had his hand up.
Yes, I was going to go to it.
Okay.
DP Paul, go to your time.
Yes, thank you very much, DP Stewart, and also thanks to Ms. Black for this enlightening presentation. What is sad is that what is sad to hear that many people are not really prepared about for an earthquake or the aftermath of an earthquake should one occur in Jamaica. And I live in a country, a city where at least twice a month I feel an earthquake, whether 5 or 4, whatever strength it is, but it's all about getting prepared and have your necessary kit to move should there be a 7.0 earthquake or 8, we don't know. And all this probability I'm talking about, if it occurs, should not, we don't know when it will occur. Just reflecting that last month actually in Tokyo, we were issued with an alert about a strong earthquake, or to prepare for a strong earthquake which could occur anytime. And with that, many people in Japan became very nervous and started to panic and buy water and all food supply and everything in storage. You know, so I guess Jamaica should also take that approach and encourage the citizens to get long shelf life water that lasts for like 5 years, biscuits that last, long-lasting cookies, energy cookies that last for at least 3 years in storage, and a necessary kit that they will need in case an earthquake should occur and how to survive, so as to minimize loss of life and so on. So, that you need to push that narrative for the population in Jamaica to go forward in terms of preparing themselves mentally.
Let me ask you this before. Did an earthquake, has an earthquake yet occurred based on that warning? Well, you said they have them all the time, but
yeah,
you didn't get a big one.
A big one, maybe like 6, but of course it won't consider major, but they have had big ones after that one occurred. Is it a month ago? So they have had big ones, but I would say 6 is not really. 6 is considered big maybe in some jurisdiction, but it's normal here. But the fact is that the citizens became they were panicking, so they buy all these they have these waters that they get. Like they stock up on waters in the garage and so on that can last for like maybe the shelf life is about maybe 5 years for a bottle of water. I don't know if it's safe to drink after 5 years, but I guess they package it. And biscuits that you'll eat, cookies, energy bars that last for 6 years.
So are there any other tips that they give you in Japan? I mean, as to what you can do?
Yes, they do. They give us, I mean, each person would have a bag like this.
Oh, what's it? And tell us what's in it.
The bag has in a flashlight, dust mask, a first aid kit, surgical tape, a pocket raincoat. It has in also a blanket as well in case, like a blanket is also there in case it's in the cold winter months to keep you warm. An aluminum blanket. Matches, candle, and also an helmet.
Oh yes. Okay. Well, thanks for that, Mike. You know, we not. I don't think anybody in Jamaica has any kit like that. That is
So of course. I mean, we all have to be. We all have to be prepared because we never know when a 9.0 will come, and you have to run out and leave everything behind.
So, what, you live in a high rise?
Yes. I live on the 14th floor in my building. Yes.
And how tall is that building?
That building is, I'm on the last floor. So that's.
Oh, so it's 14. Okay.
Yes.
Okay.
I mean, but there are buildings with 50 stories. Yeah.
All right. Thank you for that. You know, giving us an idea of what's happening at another corner of the world.
Yes.
Okay. I don't see any more hands up. One. Oh yes. Ms. Black, would you like to just put a wrap on what you have, you know, you said you paused at that point. If you wanted us to put a little capsule and finish, how would you like to end it? Hello? Are you hearing me, Ms. Black? Can anybody see it, her?
I'm searching, but I think we lost her. I don't see her. I'm still on.
Okay. I don't know if she lost her connection. But
yeah.
But then okay, well we can't do the voter thanks without her being on. So let us do what else you have to do.
Yes.
And then if she comes back on, then we can do the voter thanks.
We can do the voter thanks.
All right.
All right. Thank you, DP Stuart. Since we are slightly over our time and in bar time, we will move straight to the Sergeant of Arms, Chairman Zuri Johnson.
Thank you, President Newton. Good evening, everyone. So we're going to be doing it very quickly this evening. Why are pediatricians considered short-tempered? Because they have little patience. So we're going to be doing the charge a little different. It's back to school, so I figure that instead of charging you today, I'm going to just do a blanket charge and ask you that you make a donation to a child for back to school. So I know I can trust you because you're a man of your word. So make sure, just find a child and make a donation. That is the charge for this evening. Have a good evening.
Thank you, Chairman Zuri. Very up charge this evening, sir. And I hope anyone any member of the Kiwanis Club of Kingston who doesn't do that, then I hope they have a guilty conscience for the rest of the year. Next, we're going to have notices and announcements and interclubbing opportunities by Secretary Willie Reese, who has finally got his internet back, so he's on with us. DLG Willie. Oh, you're still muted, DLG. We're seeing your mouth moving, but we're not hearing any words. You're still muted officially. All right. We're not. DLG Willie is not making it on. So what I'm going to do is we know that the next DCM will be Sunday, September 15th. In St. Thomas. Maybe if LG Desmond is still on, you could say something about that. LG Desmond. We also invite New Kingston. I know there are several persons from New Kingston on. We invite New Kingston to also tell us about their 35th anniversary celebration. So LG Desmond, fourth quarter DCM. DLG Desmond not on? Okay, well, most clubs would have known by now that the fourth quarter DCM is on September 15th. It is at a location in St. Thomas, which I understand.
Sorry, just said Division 23 Central.
Oh, yeah, yes, 23 Central. Sorry, I just remember we have visitors. Thanks for that, DP Stewart. And I understand that this location is like 25 minutes drive from Harborview, and that information will be distributed by the various clubs to the members. Is there anyone from New Kingston who wants to tell us now about your 35th anniversary celebration for tomorrow?
Okay, thank you, Prez. Yes, tomorrow evening at 6 p.m. at the Police Officers Club, we will celebrate our 35th anniversary. And we are asking for shades of pink. That's our theme, color scheme. Men can wear your pink shirts if you want to. And it promises to be a very good evening. And the cost is $2,000. So please, if you can support us, we would appreciate 35 years is a long time. So please come on out and enjoy yourselves tomorrow evening.
Even if you don't have a pink shirt, right?
Even if you don't have a pink shirt, you can wear a white shirt or any other. No, men don't like pink, right?
Okay. All right.
But you can wear your yellow shirt, anything that you want. But please be there. Don't let that stop you.
Okay, we will be there, and I hope to see everyone who is on this program tonight there.
Yes.
Okay. All right. At this point, we're going to ask DP Marcel to bring us his thought for the week. DP Marcel? All right. DP Marcel is not on. Is our guest speaker KARLEEN Black back? KARLEEN Black?
Yes, I spoke to her and she was trying to get back in. So I'm not sure if she's in right now. Maybe I'm looking. But she did say she got kicked out. I mean, she lost her connection.
Okay.
But she was about to try and get back in.
Okay.
Since she hasn't answered yet, then you could do whatever else.
Well, we will, I know PD David was prepared to give the vote of thanks, but we cannot give the vote of thanks without the guest of honor, so our presenter. So I just want to say on behalf of the club, thanks to her for an amazing presentation. I'm pretty sure many of us now understand earthquake a little better. It's not just shaking. We understand what's causing the shaking, why it's happening, and also thanks to
All right. Let me
back?
suggest this. Let me suggest this. We can do the vote of thanks because I can still send her the tape and she will hear it.
That's a good idea. Very good idea. So at this point, we ask PD David Hall to give the vote of thanks to our presenter.
No problem at all. Thank you, President Newton.
Thank you, sir.
All right. So Ms. Black, we want to thank you very much for a very detailed presentation, one that has taken us to a greater understanding of the whole matter of earthquakes. We are not unfamiliar with disasters in Jamaica and the Caribbean, but what has happened is that with a number of earthquakes in recent times, that's a year back. Welcome, Ms. Black. So we want to say thank you very, very much for a very detailed and thought-provoking presentation. I listened to you, and a lot of us could just grasp bits and pieces, but certainly you gave us food for thought and a lot of information. What has happened is that the last couple of months has caused some persons to WhatsApp the predictions of what people are saying. Some have listened to the experts like yourself and others, and some have gone to scripture. Mark 13, verse 8, for nation shall rise against nation and kingdom against kingdom. And there shall be earthquakes in diverse places. Some have gone to scripture to see what is next. But I want to thank you and say that you have certainly given us a good understanding, those different aspects of the impacts and what we ought to do, but certainly an awareness. I just want to say that I had seen a couple of years back the map that the air traffic controllers have, and they look at it and you see all the dots on the screen, and those are planes in the air, and you wonder how they manage that. But you have done the same thing to us tonight, where that seismic map shows all these earthquakes covering Jamaica and shocks. So it causes us to just plan better. So I want to thank you very much on behalf of our President Newton, and the Kiwanis Club of Kingston for an excellent presentation. And we look forward to continue interaction with you. Thanks very much.
And let me just add. Yes, let me just add that I was having some problems with my publisher, the app, and I have not been able to prepare your a certificate of appreciation, which would normally be displaying at this time, but it will be done because I sort out that problem in another day or so. And I had said earlier before you got back on that we were going to go ahead and do the vote of thanks because I'm going to be sending you the tape. And you would still have been able to hear it, but I'm glad you got back on in time. So thank you once again from all of us.
And thank you all. It was my pleasure.
Thank you, and I must being a person who has said sometime enough. I have to make sure I put in my personal thank you also to Miss Black. I mean, PD David did a wonderful job, and DP Stewart had to put in his piece, but I too have to say on behalf of everyone here, thank you. It has been really edifying, your presentation this evening, and it also helps to allay some of the fears we have, because the more you understand something, the less fear you have of it. So I also want to say thank you.
Thank you.
All right. At this point, it's now 8:47, and as our tradition goes, I'm going to ask everyone to raise their glasses and raise a toast to Kiwanis International, Jamaica, land we love. This was a beautiful evening. We hope no earthquake come to spoil it, but at least if it happens, we know what's happening. And so at 8:48, this meeting of the Kiwanis Club of Kingston is now terminated. We thank you for coming. Thank you for staying with us. We know we are slightly over the time, but it was an important topic that had to be carried to the end. Remember, we meet each Tuesday, same time, same Zoom coordinate, and we hope to see you in the coming week. So thanks and good night. DP Stuart, will we be having music tonight, sir?
Oh, I was trying to say something and I didn't realize I had muted myself. I was just gonna say that next week, we're gonna be tackling the topic of artificial intelligence. So I just wanted to let our current audience know in advance. So it's gonna be very interesting. And yes, I'm gonna play some music tonight.
Okay, thank you, sir.
Okay.
All right. You're doing artificial intelligence next week, right?
Yes, that's what I was trying to say.
We know you tend to pull a rabbit out of the hat all the way. You're having a cyborg on next week?
A what?
Cyborg.
No.
Are you inviting Elon Musk on next week?
No. No.
We know you're capable, you know.
I'm not a fan. I'm not a fan. Let me state that.
President.
Yes, sir.